Now we do some numericals on electric potential. So in this question, what is it say that what is the potential difference between the terminals of a battery? Terminals of a battery, there are two terminals of a battery. One is positive terminals, another negative terminals. So if 250 joules of work is required to transfer 20 coulombs of charge from one terminal of the battery to the another terminal. It says that if I transfer 20 coulomb charge from this positive terminal to the negative terminals, I have to do some work done. That work done is 250. So we need to calculate the potential difference between A and B. Since A is the higher potential, this is the higher potential, it connected directly with the positive terminals, and this is a negative terminal, it connects to the B point. B point will be lower potential. Therefore, potential at A greater than potential at B. So from the potential difference, we already know that the potential difference is equal to work done divided by the charge transfers from these two, between these 2 points. So here the potential difference at A, we can also write this potential of A point greater than potential at B is equal to work done divided by Q. So we need the left hand side part, and W and Q is already given. W here work done is equal to 250, and the charge transfers from one terminal of the battery to the another terminal is 20. If I divide this quantity 250 by 20, it comes out 12.5 volts. So potential difference as the unit volts. Either you write in volts or write only in capital letters 2.5 volts. So 2.5 volt will be the potential difference between these 2 points. Now we have another questions. Question number 2. How many electrons are there in 3 coulombs of charge? So its answer will be, first of all, we have this question Q is equal to N into E. This is the formula we have. N is the number of electron. N is the number of electron, and E the electronic charge which has 1.6 10 raised to the minus 19 coulomb. So this is our formula. It says that how many electrons in 3 coulombs contained. So Q here Q will be 3 coulombs, and we need a number of electrons in this 3 coulomb. Using this formula, put the value of Q here 3, and another number of electrons which contained in 3 coulombs, E the electronic charge which has the value 1.6 10 raised to the minus 19. Now from here, N will be 3 divided by 1.6 10 raised to the minus 19. After simplification, so you remove this decimal 6 with 10 divided by 16, and 10 to the power minus 30 goes in the numerator, will becomes 10 raised to the power 19. So now it is divisible by 2, 2, 8 and 15, and now directly if I divide this one 8 8.8, and this comes out 1.85 10 raised to the power 10 raised to the power 19. So these are the number of electrons. These are the number of electrons which contained in 3 coulombs of charge. 3 coulombs of charge. So this is our formula. This is the formula we have utilized here. This is another question. So how much energy is transferred by a 12 volt power supply to each coulomb of charge which it moves around a circuit. In a closed circuit, there is a battery. There is a battery whose potential is 12 volt. We have to supply 1 coulomb of charge. We have supplied 1 coulomb of charge. Your charge is good here. 1 coulomb and potential difference is equal to 12. The energy supplied. We need the work done with the battery done. So you know that we know that potential difference is equal to work done divided by work done divided by the charge. Okay, whatever the work done, that work done is stored as the energy. It means that the battery will do that much of work done. It means that the battery will lose that amount of energy. Therefore, the work done or energy supplied by the battery supplied by the battery is equal to potential difference multiplied charge. Our potential difference is 12 volts and charge is 1 coulomb. 12 into 1 coulomb comes out 12. Means work done as a unit joule. So energy supplied also as the energy joule.